Hi, hello, welcome to VHDL Basics. Today we are going to see about ring counter in VerilogHDL. So first of all, we need to know what is ring counter. Ring counter is a digital circuit with a series of flip-flops connected in feedback manner. Ring counter is composed of shift register. The data pattern will recirculate as long as clock pulses are applied. A ring counter is typical application of shift register. The ring counter is almost the same as shift register. The only change is that the output of the last flip-flop is connected to the input of the first flip-flop in case of ring counter, but in other case of shift register it is taken as output. Except for this, all other things are same. Number of states in ring counter equal to number of flip-flops used actually. Here if you see, I am creating ring counter which has 4-bit width actually. So there are two inputs, reset and clock, and output will be with -1 down to 0 actually. Here width is 4, which means this is 3 down to 0. So I'm inside always I'm checking false edge of clock as well as neg edge of reset. So this is asynchronous reset. So I am checking whether reset is 0 or not. Once the reset is 0, I am assigning 1 to the output ring counter, and if reset is deasserted, then we need to do the shift operation. So this is the so using concatenation I'm going to do the shift operation. So the syntax for concatenation operation in Verilog is nothing which is used inside curly braces actually. If you see here, the curly brace, open curly brace, and then I'm giving um, ring counter with -2 down to 0, and then the MSB bit of RC out I am having in the LSB bit of the ring counter next time. So this is how I am planning to connect the last flip-flop output to the first flip-flop input. So the next clock cell will have the MSB bit will come into LSB bit of the ring counter. Now I am going to simulate this and I will explain with the waveform. So this is the test bench of the ring counter. So here you see parameter width. I am here. Initially I am having 4. So the number of states with in the ring counter will depends on the width of the ring counter. So if it is 4 means there will be 4 state uh, of the ring counter will be generated. If it is 6, there will be 6 state will be circulated whenever clock is there. Okay, so I'm using input reset clock as a reg, and I'm declaring wire RC out as a wire with -1 down to 0. That is the width of the RC out. So I'm instantiating the ring counter. Line number 6 to 10, we are doing the instantiation of the ring counter. And in the initial block, I'm asserting that reset first and giving the initial value of the clock. After 40 nanoseconds, I am giving reset. I am deasserting the reset of the ring counter. In always block, I am generating the clock. Here 10 nanosecond. Every 10 nanosecond, the clock will be inverted, which means I am generating 50 megahertz clock here actually. So I'm going to explain the waveform now. So this is the output waveform from the ring counter. So if you see, initially the reset is asserted. At that time, I am assigning 1 to the counter output. That's why I'm getting here 0001 actually. After that, once the reset is released, rising edge of the clock, we are doing the circular shift actually. So here, if you see, the MSB bit is assigned to the LSB bit. Likewise, it is shifting. Once it is coming to one is coming to the MSB, again it will go to the LSB bit for the next clock cycle. So if you see here, 0001 and 0010 and 0100 and 1000, these are the four state present in this 4-bit ring counter. Again it will start from the 1001 and it will recirculate it actually. Now I am going to change the width of the ring counter. So instead of 4, I am going to give 6 here. Now I am going to simulate this and I will explain with the waveform. So this is the 6-bit 6 6-bit with ring counter. If you see here, 5 zeros are followed by 1 when reset is asserted. After once the reset is deleted, the 1 is shifted to the second LSB bit, and then again it is shifting like this, and once it is coming to the MSB, again it will go to the LSB bit. So here if you see 1 2 3 4 5 6 6 sets are there. So number of width actually width is matching with the number of state present inside the ring counter. Hope you enjoyed this video. Please like, share and subscribe this channel for more videos.